Okay, let's continue. There's one caveat with permutations, and that particularly is when your permutations have a choice that repeat. So a word like set, we could write down all the permutations. It's S-E-T, S-T-E, and start with E, E-T-S, E-S-T, and then start with T, T-S-E, T-E-S. Those are the 6 combinations for set. For something like Anna, A and A, you have A and A, but if I switch these two A's, it's still the same word. So the only thing I can really do is control where the N is. So even though these are the same number of letters, because it's at a repeat, there's actually less combinations. So generally speaking, the number of permutations of N items with identicals, P identicals, Q identicals, R, is you just divide by however many identicals you have factorial. So for like Mississippi, count the number of letters. There are 11 letters. The total number goes in the numerator. So we have 11 letters. We have 4 M's, 4 I's, 4 S's, and 2 P's. So I need to put a 4 factorial in the denominator for the I's, a 4 factorial for the S's, and a 2 factorial for the D's. Now if you're putting this in the calculator, make sure this is in parentheses, otherwise it'll divide and then multiply. So looks like this is 34,650. I'll let you do 2 and 3. You can check it on the completed notes on Canvas. We'll do 4 though. How many different vertical arrangements are there of 10 flags if 5 are white, 3 are blue, 2 are red? This is exactly the same as the letter problem, only the repeating colors are the repeating letters. So it's 10 flags total in the numerator. We need a 5 factorial for the whites, 3 factorial for the blue, and a 2 factorial for the red in the denominator. And this is 25, 20. Now these are still permutations because order matters. Now what happens if order doesn't matter? What if I tell you that I'm going to pick 5 people randomly from the class and give them a $20 Starbucks gift card? Do you care if you're the first person picked or the 5th person picked, or do you really just care that you were picked? I don't mind a Starbucks gift card. So combinations work similarly, equation-wise, to permutations, but it's slightly different. Equation-wise, USA Today talked about 6 movies and rock stars that have achieved cult status after death. You're going to do a documentary on 2 of these stars. How many different ways can you pick them? We could write these all out. But we have Marilyn Monroe with Janis Joplin, Marilyn Monroe with Jim Morrison, James Dean, Jimi Hendrix, Kurt Cobain. That's all the Marilyn Monroe combinations because the order doesn't matter. So Janis Joplin with Jim Morrison, Janis Joplin with James Dean, Janis Joplin with Jimi Hendrix, and Janis Joplin with Kurt Cobain, and Jim Morrison, and then Janis Joplin with Marilyn Monroe is already covered here. Jim Morrison plus James Dean, Jim Morrison plus Jimi Hendrix, Jim Morrison plus Kurt Cobain, James Dean plus Jimi Hendrix, James Dean plus Kurt Cobain, and then finally Jimi Hendrix plus Kurt Cobain. So you can see that there are 15 combinations, which is actually less than there were previously. So what does that mean for us? Well, because they're Marilyn Monroe, Janis Joplin is the same as Janis Joplin, Marilyn Monroe, because it's the same documentary. if order doesn't matter, you have an extra thing you're dividing by. So this part looks exactly like the permutations. This part is new. There's an extra number in the denominator. I think combinations are easier to remember because the two numbers in the denominator add to the top. So when you see 7, choose. So in your calculator, this will be the NCR button, and you put the number before and after. The number in front is always the numerator, and then the second number is the denominator. It's the number you're picking. And then if you subtract these two, that's the other denominator number. So you notice 4 plus 3 is 7. So this is a little bit easier. You can either put this in the calculator or put 7 NCR into the calculator. This should be 35. 8 choose 5. It's 8 factorial over 5 factorial and 3 factorial. Should be 56. 6 choose 0. Be 6 factorial over 6 factorial and 0 factorial. This is 1. How many ways can you choose a group of 0? Well, just one way. You don't pick anything at all. Okay. So now we're going to see some more problems that look similar but are slightly different. 20 equally qualified friends go into business together. They need to pick a group of 3 people to act as the bosses. How many ways can they pick these? So this is different because we no longer have a CEO and treasurer compared to the previous one. Now they're just all bosses. So does it matter if you're the first pick to be boss or the third picked, or you still get to be a boss? You still get to be a boss, so this is why order doesn't matter. So there's still 20 people in the numerator, but instead now there's a 17 and a 3 in the denominator. This will be 20 times 19 times 18, or 3 times 2 times 1. This will be 3. This is 18 divided by 6, so 570. This should be 1140. Now, one thing you notice about combinations is there's always less than permutation. So you're always dividing by an extra number. So unless that number is 1, you'll strictly have less. If that number is 1, it can be the same amount. For example, like 6 choose 0 and 6 permute 0 are both 1. In poker, a person is dealt 5 cards from a standard deck of 52. How many different poker hands can be dealt? Again, the order doesn't matter. If you get 4 aces then a king, or a king then 4 aces, if it's the same king, it should be the same. So again, this is 52, choose 5, or 52 factorial over 5 factorial, and subtract them to get the other number, 47. This is a large number. So one way to simplify this, if you wonder how I'm doing this by hand, is take the bigger number in the denominator and write out all the numbers until you hit the bigger number. So 52 all the way down, but I stop when I would be hitting 47. That rest of it cancels out the 47, and then write out the other number. 5 times 4 times 3 times 2 times 1. And there you can reduce if you want. These will always reduce. How so? 50 divided by 5 is actually 10. 52 divided by 4 is 13. 51 divided by 3 is 17. 48 divided by 2 is 24. Now all the numbers in my denominator are gone and I can just multiply. So if you're someone who's doing these all by hand, it is possible to do it by hand. Either way, there are 2,598,960 poker hands. And we will continue in the next video.